Hello and good morning, everyone. Welcome to this session about Salt at SUSE, how we use Salt, what we do with Salt. My name is Klaus Kampf. I'm the product owner for SUSE Manager. So SUSE Manager is our flagship product using Salt. If you don't know what a product owner is, then you are not doing Agile yet, and you should. So I'm kind of the guy who does all the balancing between what do we do next? Do we fix bugs, which for the existing product, or do we develop features for the next product? And I have with me Pablo. Pablo, please.
Yeah. Okay, so my name is Pablo Suarez. I'm part of the development team of SUSE Manager. Mostly focused on the Salt integration with SUSE Manager. Let's talk about how we use Salt at SUSE.
Okay, now let's see, too far away maybe. Yeah, okay, so what is our agenda today? So a bit about SUSE. Not everyone here might know what SUSE Linux is actually doing. Then, Salt and SUSE, so where and how do we use Salt? Then a bit about our ways to ship Salt. So what is the way from an upstream Tarball release to the actual enterprise product? How do we do it? And then also, what do we do in terms of quality assurance, hardening Salt? We have a couple of tools, and Pablo will talk about this later. We have a Q&A session at the end, but during the presentation, feel free to raise your hand, catch my attention, and I'll try to answer. Okay, so about SUSE. SUSE Linux is actually the oldest SUSE Linux company in the world. We celebrate 25 years this year. We were the first to release an enterprise Linux. We have also a community distribution, which we call OpenSUSE. And the OpenSUSE has actually two distributions. One we call OpenSUSE Leap, which is a combination of the enterprise base. So Leap has the enterprise kernel plus a relatively up-to-date userland. And the other distribution is Tumbleweed, which is a rolling release with sometimes daily updates. So there you get really the latest and greatest. You get the latest kernel. We shipped GNOME. I think current version is 3.26 within 1 or 2 days of the upstream release, completely packaged, tested, and so on. We have a couple of commercial offerings. First of all, of course, our SUSE Linux Enterprise server. Then we have a desktop. We have a storage product. We have an OpenStack cloud. We have a container Kubernetes product called Kampf platform. And we have SUSE Manager, where Pablo and I are working for. And look at www.opensuse.org for the community distribution. So, a bit about why Salt. About 4 years ago, actually it was 5 years ago, I had the honor to meet Mark Burgess. So Thomas Hedge just mentioned that he is really the inventor of config management. And back then, I really got into this. I packaged CF Engine for SUSE. I'm still the package maintainer. I looked at Puppet, Chef, and all these tools. And I looked a lot at infrastructure as code, this buzzword everyone is using for configuration management. But what I've actually found, and what I heard from a lot of people talking to at conferences, is code, if you don't maintain it properly, if you don't refactor, if you don't clean it up, it pretty soon evolves to infrastructure as spaghetti code. You probably all know this. And this is where we said, well, we don't just want to use a configuration management system, but we want to have structured data. Not just files in a Git, which are edited and grow beyond belief, but we want it structured. And this is where SUSE Manager comes into play. This is our mascot, the tamed hedgehog. SUSE Manager is about taming IT. So what is SUSE Manager? SUSE Manager is basically a centralized Linux management platform. You have a central console, you have all your managed systems, and you can deploy software, update, patches, redeploy. It is based on an open source project called Spacewalk, and it has a Python agent running on the managed system. And looking at this Python agent, it was very hard to keep it up and keep it maintained. And the agent is really only focusing on software management. Of course, we want to do more. We want service management, network management, storage management. It's hard to port. If you want to manage more than just Linux systems, that wasn't cutting the mustard. And also, we had to look at where do we provide value. And just a management agent does not provide value. Anyone can write a management agent. The value is when you combine new things and innovation with existing open source software. And this is exactly what we do on SUSE Manager. So in SUSE Manager, we have all the configuration data in the database where it's structured, where it doesn't evolve to spaghetti code. And from there, we generate salt states and deploy these to minions. You can still write your own states, but this is really key to us and where we focus, that we try to keep the data structured. What is nice about how we did this in the SUSE Manager engineering team, so I just told the engineering team, go find a configuration management system which integrates nicely with SUSE Manager. And they choose Salt. And I don't have to tell you why we choose Salt, but it's one of the nice things at SUSE that from an engineering team decision, something much bigger evolves, like our partnership with SaltStack, which we announced last year, and which is really going well. So SUSE is, meanwhile, one of the main contributors to Salt. We have regular engineers exchange, and this is really going well. So what did SUSE contribute to Salt? This is just a small list of things. As you can see, we have a couple of pull requests open. And I just want to highlight the newest addition one of the SUSE Manager engineers did. It is an Ansible gate. So because what we see...
That's a bad word, isn't it? Ansible?
No, it is what people use outside if they don't know Salt. And they say, hey, I have these, what is it called in Ansible, playbooks, and I want to reuse them. So if you are approaching a customer who says, I've so much invested into Ansible, I can't move to Salt. Yes, you can. So it is not merged yet. It is still in discussion. Yeah, but these are the things we try also to achieve. Okay, let's look at how Salt is used in SUSE products. And that means the enterprise products. So, said before, SUSE Manager embeds Salt Master, and you can use the Salt Minion as the management agent. You can also use Salt SSH with SUSE Manager. You can do agentless configuration, especially if you have a setup where only your central administration system can open a network connection to the outside. I mean, the normal connection setup is that the minion contacts the master, but many of our customers have the central server in a shielded, firewalled data center, and the minions outside, and they can't use this means of communication. SUSE Enterprise Storage, it was mentioned by Joe Werner in today's keynote. This uses a tool called DeepC, which is open source, which you can find on GitHub. So DeepC orchestrates not only the deployment of the various nodes, so storage is based on Ceph. We have a clustered setup, and you have admin nodes, and so on. So DeepC not only orchestrates that, but when you roll out an update, it also orchestrates how the update is deployed, and that nodes are updated one by one, and when an updated node comes back up, the next node can go down for an update, but the whole cluster does not go down and still is reachable. And one of the latest additions to the portfolio is SUSE Container as a Service Platform, a rather complex name. What this is, it is a simple setup of a Kubernetes cluster. For minimum 3 hosts, it comes with an authenticated registry, which we call Portus. Also online, one of the highest liked projects, actually, SUSE projects in GitHub. And we just released an update to SUSE Manager, so SUSE Manager is even able to connect to the Kubernetes, and you can manage then running containers, and you can check them for compliance. Okay, looking at how we ship and what we ship in terms of Salt. So the enterprise products, that is SUSE Manager, storage, Container as a Service Platform, are a bit more conservative. So they are still on the 2016.11.4, which has seen a lot of testing inside, and our plan is to update this roughly every half year to a year. The OpenSUSE distribution is the leading edge. So there we ship 2017.7.2, the latest Salt upstream, which also gets a fair amount of testing, but not so much for the enterprise. The enterprise Salt is fully supported. So if you are a SUSE customer, you have a problem with Salt in one of our products, we also ship Salt as part of the SUSE Linux Enterprise. There, it's not in the base operating system. It's part of a separate repository we call a module. If you have any problem, you can pick up the phone, call our support, and we will help you. Okay.
If I call support, will you help me, or will somebody else?
I won't help you because you know best how to do things. But yes, we have several levels. So the front line is called level 1. And if it goes to, if front line and back line, level 2 can't help you, it gets to an L3, and it will come to my desk. And I will see your bug report, yes. And I will ask all kinds of funny questions like, send me your log files, send me your states. OK, so let's look how we ship Salt. Yeah, so we do RPM packages of Salt. And we follow a normal development cycle of development, testing, and production. And all we do with this is in the open on GitHub. So what we have is, and actually we do this 2 times. Once for the enterprise distribution, and once for the OpenSUSE distribution. And there, so usually we have one stable thing. Then testing is a patch or 2 on top of stable. And then we also have a development branch which tracks the next version. So for OpenSUSE, for example, we currently track the devel branch of upstream SaltStack, fully automated. As soon as a commit is made upstream, we download the source, we package it as an RPM, and then our test harness starts. So if you want the latest, greatest upstream as a package, we have you covered. All this is available in what we call the OpenSUSE build service. OpenSUSE build service is a package build framework which builds packages from source, and it automatically rebuilds packages when dependencies change. So for example, if a new lib0mq comes out, or a patched lib0mq, our Salt packages get automatically rebuilt and retested. I don't want to go into detail. This is more for your reference. The slides are already available for download. So for the enterprise product, you have seen we have a build service product called products. This is basically production. We have products testing. This is the test. This is production plus 1 or 2 tests. And then next is really a future product. All we do is in the open. So check the OpenSUSE organization on GitHub, and there is Salt. And there's our Git. And there's also a wiki explaining what we do and how we do it. And of course, we love contributions. So this is just a screenshot of the OpenSUSE build service. So you have, it's hard to see, but these are the files which are used to build, and these are the distributions we build for. And I read it for you. So we build for Fedora 26, we build for RHEL, we build for /11, we build for /12, and we build for OpenSUSE. OpenSUSE build service can also build packages for Debian or Ubuntu. The only thing missing here is someone contributing this packaging to us, because we have no one in the current team of Salt maintainers who has knowledge in Debian packaging. But that could be a single stop for all your package needs. And this is a page from our wiki, which explains how we build source, how we track changes, how we handle pull requests, code reviews, and so on. As I said, it's a reference. Please download the slides, and then hope to see you on GitHub. All right, hardening salt.
Okay.
Pablo, that's your part.
Please. Okay, thank you, Klaus. So we have seen that that SUSE is shipping salt for OpenSUSE, but it's also shipping salt as part of a core component for the enterprise product. So Klaus already said that if we are shipping salt for enterprise product, it means that we have to support it. So we need to ensure that our package is strong enough. Otherwise, we will start receiving bug reports. So enterprise means that we need to do a lot of testing on top of the salt package. So we face our first challenge here, which is, okay, we need to have certain infrastructure, testing infrastructure, which allowed us to test it properly, to run the SaltTag unit and integration test, not only for our latest SLE version, but also for all the version of the distribution that we are currently supporting. So we face this challenge, so we need a way to define all our CI infrastructure. It needs to be we need an easy way to apply, modify, and be able to reapply those states. We are a group of people, so we also need that this could be maintainable by multiple users. We also want to keep it simple. We don't want to add extra services that we need to also to maintain. So what we this is the solution that we first came out. That is, okay, let's create a GitHub repository. Let's put all our Salt tree or SLS files and all the needed files that we need to configure our infrastructure there, and also set this Salt file, which allows Salt to not use the default ATC Salt environment, but a specific and custom environment that we provide inside the GitHub repository. So, as I say, we set SLS file, a state that define all our infrastructure, and then we use Salt SSH. With Salt SSH, we don't need to have a Salt master, and we don't need Salt minions. So this is a more or less fixed infrastructure. So we don't need to deploy this to thousands of machines. So Salt SSH is good here. It also enables us to follow a pull request workflow. So if any one of our team needs to do some changes in the configuration of the infrastructure, we can just create a pull request, then it will get reviewed, and at some point it will get merged into the repository. So when it gets merged, it's as simple as apply the state or run the high state in the desired machine. So it's a really easy and portable solution to setting up our CI infrastructure. Oops, sorry. So testing. We have now our infrastructure. Now we need to test. We need to run the Salt test. And as I said, not only for the latest SUSE distribution, but for all the currently supported distribution. So the first thing that this is a tool that we just developed to make our life easier. It's called Salt Toaster, and it allows you to run Salt unit and integration tests, and also your own custom integration tests inside containers. So it's based on PyTest. We use, in this case, Docker PI to manage those containers. As I said, it allows easily to switch the operating system version. So how it works? It's really easy. So it automatically prepares the image for the selected OS. It will install your Salt flavor, if maybe the devel package of Salt, or the testing package of Salt, or the production package. It will spin off the container, run the test, report, and then it will remove those containers. And it's very easy to run. So, for example, this one will run the Salt Stack integration test. The next one will run Salt Stack unit test using these two, using the default OS image that we have configured. And the third one will run our custom integration test made within Salt Toaster. You can see here that we can also run Salt Stack integration, but in this case, we say that, okay, we want to run it using /12fp1, and we want to use the product's next version of the Salt package. In the same way, we want to run the SUSE custom integration test using rel 6, using this flavor, and we only want to run this specific test. So it's very flexible. This is just an example of how a custom integration test made by Salt Toaster. So yeah, this will check the epoch of uninstalled packages. You see that we said, okay, we want a Minion. So it will create a Minion container. And then we can execute Salt calls inside the Minion. So in this case, pkg install, test package. We just add a finalizer here, and we just check that the package info installed after installing the package is reporting the right epoch. And that's it. We have here an integration test. Just a few other ones. In this case, you can see here, this is for checking that the Salt version reported by the installed RPM is the same version that is reported by Salt on the grains. And the interesting thing is that you can access the container and run whatever shell command that you want. Then we also make a Salt call to get the Salt version from the grains, and we check that everything is fine. Okay, we have here another example, just for test the package remove. So it's very easy to implement those tests and run it using different containers and using different OS version. Okay, so at this point, we have our Salt package. It has been tested. Our tests are green. So let's now test our SUSE products using this package of Salt. Okay, so in the case of SUSE Manager, we have this tool that has been written by one of our developers, Silvio Moioli. It's based on Terraform. Terraform is a tool that allows you to define your infrastructure, set dependencies between the different machines that you want to deploy, and also make it modular. And it's very quick to deploy things here. We can deploy machines and set up environments in libvirt and also in Amazon Web Services. It's widely used for our SUSE Manager development team. It's really easy to use because you have a main TF file where you just said, okay, I want a SUSE Manager server with this image, so it's /12fp2. I want the version nightly, the 3.1 nightly version. I also want to spin off a proxy and also a Minion, which has in this case a /12sp1. So we define here our infrastructure. We can also choose different, as you see, base images. We can even use rel minions here. And then it's as simple as, okay, let's check that everything's compiled. Let's make the planification about how machines should be created, because maybe I already have my SUSE Manager server up and I'm only adding a new Minion to test. So it will show you the plan and just Terraform apply in order to apply, and that's it. Just to see, we have here our how it works internally. So we have our main TF definition. So the VM is created, even on either on libvirt or Amazon Web Service, and then we set a specific grains to set the role of this particular machine. Maybe it's a SUSE manager server, a proxy, or just a Minion. Then we copy the summa for salt tree to the machine, and then we can execute to apply the high state, which based on this grain definition will apply and set up all the needed stuff for the role that we have selected for this machine. And once it gets applied, we have it. We have now our SUSE manager infrastructure where we can run on top of that our Cucumber test suite and just do whatever we want. So the next challenge is, okay, let's test how this Salt or our Salt infrastructure with our extension modules, external pillar, and all the stuff that we put on top of Salt, how it scale out. For that, we have this evil Minion tool. This was also written or started by Silvio Moioli. It's basically a load generator for Sol Open, but it allowed you to simulate thousands of minions, but with a minimal amount of hardware and memory. They are not real Sol minions, they are evil minions. They base their behavior in a previously gathered, in a previous dump of zero-in-queue traffic that we have created before. So it will allow us to run massive tests, for example, using Amazon Web Service, where you can just deploy 20K evil minions in seconds, and then test how your Sol master reacts to such a load. How it works? It has two steps. So the first one is we need to create this dump of the traffic. So we run this dumping Sol minion, which basically is a Sol minion process, but it just, apart from responding to the zero-in-queue ports, it also save all the messages that are going across the zero-in-queue bus. So you just run the dumping Sol minion, then you accept the keys, run states, run commands, and so on. And then this dump file is going to be populated. So at some point, we just stop this dumping minion, and now we can run our evil minions using this dump file. And as easy as evil minion, the number of evil minion that we want to simulate, and the master FQDN. How it works, basically, as I told you, we have this dumping Sol minion process, which just inspect all the zero-in-queue traffic for these minions and save it in a message pack dump file, and then we can run the Sol minion. So based on this dump file, the evil minion will create the event loop, and then it will create the number of instances of evil minions that we want, and each one of these instances is going to create the two connections with the Sol master for the pub channel and the red channel. So the Sol master is also actually holding all those connections, and then, but this is a lazy minion, because what it does is, okay, it will just listen for events that come from the master, and then it will check, okay, I have this event, I will change, of course, the evil minion is smart, so it will change the minion ID, and it will create a separate minion ID for each one, and then it will behave in the same way. So with this, you can, for example, say, okay, let's see what happens if I schedule a package installation or a patch installation with a lot of package on it, and what's happened when all of these, and I target the package installation to 20K minions. Let's see what's happened when all the minions are responding the returns event to the Sol master. The Sol master needs to save all the job return messages, and then you can start doing measures about where are your limitation in your Sol environment. So it's a really nice tool, this one. And yeah, that's basically it. So conclusion. SUSE is an active contributor to the Salt Open. We will continue making contribution and improving it. We would like you to collaborate with us, maybe creating some Debian packages for the Salt that we are shipping in OpenSUSE using the OpenSUSE build service. And we invite you to also try this tool that we have mentioned. Maybe they are useful for you, or maybe they give you some inspiration for your own tuning or whatever. Of course, you can, we accept, of course, contribution here, so if you have some contribution, they are more than welcome. And of course, have a lot of fun while doing it. So that's all for us. Thank you. Do you have any question? Oh, hopefully it was clear enough.
When there are no questions, you know you either did very good or very bad.
Yeah, we don't know.
It was very good.
Okay, guys, so thank you. If you have any question or something, you can just reach us later during the conference and ask whatever you want. Thank you very much.